Algebra 2, Chapter 5, Section 2 review. Graph each function. Number 3. Y equals 2x squared plus 4. Alright, remember step 1, we're going to list our a, b's, and c values. Our a is 2, our b is 0, and our c is 4. So based on that, we know our vertex is at 0, 4. Because if our b value is 0, we know the y-intercept is part of the vertex. Okay, so we have the vertex. Now, since the y-intercept is part of the vertex, we're going to have to plot points. So, let's make x equal to 2, so we'll solve for the point right here. When x equals 2, we just plug in for y. So y is going to equal 2 times 2 squared plus 4. That's going to be 8 plus 4 is 12. So when x is 2, y is 4. We'll do 1 as well. When x is 1, so y would be 2 times 1 squared plus 4. Y equals 6. So we can plot 1 and 6. Okay, and if you remember, the vertex is also the axis of symmetry, so there's a corresponding point. If 1 and 6 is 1 unit away from the axis of symmetry, it's going to be 2 units away from the point. So I got 1 and 6, negative 1 and 6, and now I can plot 2 and 12, which is going to be way up there. So we're going to get a fairly narrow curve going vertical so we can sketch the curve. All right, number 6. Y equals negative 5x squared plus 12. Okay, again, our a value is negative 5, so we know the graph's going to go down. Our b value is 0, and our c value is 12. So we know our axis of symmetry is going to be on the y-axis, and my y-intercept is 12, so my vertex is going to be 0, 12. Okay, we're going to make each of these points worth 2 on this one. So 2, 4, 6, 8, 10, 12. So there's the 12 unit. Okay, so if we make x equal to 2, so xy, x is equal to 2, y is going to be negative 5 times 2 squared plus 12. So that's going to be negative 4 times negative 5, so that's going to be negative 20 plus 12. So y is going to be negative 8. Remember I said each of these units is going to be 1, so that's really a 2, a 4, a 6. Okay, so 2, negative 8, 2, negative 2, 4, 6, 8. It's got a corresponding point here, so you can sketch your curve. And what do you notice? It is very, very, very narrow. So my a value is very big. So the vertex is 0, 12. Okay? Easy enough. Graph each function and label the vertex. Okay, let's start with number 11. I get y equals negative x squared plus 2x plus 1. My a value is negative 1, so the parabola is going to go down. My b value is 2, and my c value is 1. So my vertex of my x value of the vertex is nothing more than negative b over 2a, which is going to be negative 2 over 2 times negative 1. So that's negative 2 over negative 2, so 1. So x value of my vertex is 1. So to solve for y, the vertex of y is just going to be, we're going to replace the x with 1. So it's going to be negative 1 squared plus 2 times 1 plus 1. So that's going to be negative 1 plus 2 plus 1. So that's going to be 2. So my vertex for this one is 1, 2. Okay, my y-intercept is 0, 1. Okay, so we could plug in another number if we wanted to. And we're going to find out my parabola is going to go down like this. with a vertex at 1, 2. All right, number 16. Y equals 4x squared minus 12x plus 9. All right, my A value is 4, so we know this thing is going to go up fairly rapidly. My B value is negative 12, and my C value is 9. So the vertex of x is negative b over 2a, which would be 12 over 2 times 4. So my v of x is going to be 8 over 12, which 4 goes into that, 3 over 2. My v of y is going to be 4 times x squared, which is 2/3 or 3/2 squared, minus 12 times 3 over 2 plus 9. Well, 3/2 squared, this is going to be 4 times 9 over 4. So the 4s are going to cancel. That's just going to be 9. This is going to be minus 6 times 3, which is minus 18 plus 9. So my vertex, my y value, is going to be 9 minus 18 plus 9. So it's going to be 0. So 1.5, 0. So there's my vertex, and it's going to go up. So I can label my vertex right here. 3/2, 0. My y-intercept I know is 9, so 1, 2, 3, 4, 5, 6, 7, 8, 9. I know my axis of symmetry is at 1.5, so 1.5 units over times 2, so 3 units over is my corresponding point. 1, 2, 3. So there we go. So I can graph this. I can plot sketch a parabola going up. Should be very narrow because my a is a very big number. Okay, a little bit of work, but we were able to follow through. Graph each function. Find the minimum and maximum value. So let's look at 23. Y equals 3x squared minus 4x minus 2. My a value is 3, so we know it's going to go up. My b value is negative 4, and my c value is negative 2. So the vertex of x is negative b over 2a, which is going to be 4 over 2 times 3, which is going to be 4/6 or 2/3. All right. To solve for y, plug this thing back in. So v of y is going to be 3 times 2 over 3 squared minus 4 times 2 over 3 minus 2. So we square it, and we're going to get 4 over 3 minus 8 over 3 minus, what's 2 over 3? So 2 to be over 3 would be 6 over 3. So negative 14 over 3 plus 4 over 3, which would be negative 10 over 3. All right, so my vertex is 2/3, comma, negative 10 over 3. So 2/3 be about right here. And my y value would be negative 10 over 3, so that'd be negative 3 1/3. So right there. So there's my vertex, and we know it's going to go up. So my vertex is 2/3, negative 10/3. My y-intercept for this one is negative 2. Okay, so corresponding units, 2/3 plus 2/3. would be 4/3. So there's my corresponding, and I can graph it going up. 27. Okay. 27 does not have a b value. 27, my a value is 2, my b value is 0, my c value is 5. So I know my vertex is at 0, 5. I know it's going to go up 0, 5. So I got to plot a point x comma y. I'm going to make x equal 1. So we're just going to plug it into 2 times x squared plus 5. So 1 squared is 1. 1 times 2 is 2. 2 plus 5 is 7. So when x equals 1, y equals 7. So I also have a corresponding point at negative 1 and 7. So I can sketch my curve. Okay? Now, a couple of word problems. The equation for motion of a projectile fired straight in the air with initial velocity of 64 feet per second is h equals 64t minus 16t squared, where h is the height in feet and t is the time in seconds. Find the time of the projectile needs to reach its highest point. How high will it go? So let's rewrite this in standard form. So h equals negative 16t squared plus 64t. So my a value is negative 16. My b value is 64. My c value is 0. Okay? So let's find the vertex of x. The vertex at x, or our time, our maximum time, is going to be negative b, which is negative 64, over 2a, which is going to be 2 times negative 16. So v sub x, they cancel. It's going to be 2. So how do I find the vertex or the maximum height? I just plug it in. Negative 16 times 2 squared plus 64t. So that'd be 2. Okay? So 16, negative 16 times 4 should be negative 64. Plus 64 times 2 would be 128. So when you add those together, the maximum height is 64 feet, and the time it takes is 2 seconds. Okay, 42. Suppose you throw a ball over a 10-foot fence. It barely clears the fence. The ball reaches the highest point directly above the fence and lands 10 feet from the fence. Using the fence as the axis of symmetry, write a quadratic function that models the ball's height. Okay, so let's look at this. So using the axis of symmetry, write the quadratic. Okay, so I know this unit right here is 10. I know this unit is 10. Okay. So I know this unit over here is 10 as well. So I can say where we started the throw was the origin. So that point on the parabola is 0, 0. The maximum point we could say is at 10, 10, or the vertex is at 10, 10. So my vertex is 10, 10. Okay. A point is 0, 0. So what could I do? How could I solve for a quadratic function? All right. Well, I could go vertex form. Y equals a times x minus h squared plus k. Well, my point gives me 0, 0. So my y value is 0. Our a value is unknown. Our x value is 0. Our h value is 10. And our k value is 10. So I'm going to get 0 equals 100 a plus 10. So I'm going to minus 10 to each side. So I'm going to get negative 10 equals 100a. So a is going to equal negative 10 over 100. Or we could say a equals negative 1/10. So my equation would be y equals negative 1/10